welcome to my video presentation on one-dimensional kinematics. Today we're going to be discussing an example of a one-dimensional kinematics problem using, of course, the four kinematics equations. I do have some other examples on my channel, but I did notice that they were all just in the y direction as far as acceleration. So I kind of wanted to do one in the x direction just so you can get the feel of it. You pretty much take the same approach, but just to see how they differ, it's kind of nice to do this one. So let's just assume that we have a boat with an initial velocity of 30 meters per second, and this boat is at 100 meters from a lighthouse. So our initial x is at 0, and the final x is at 100 meters. It tells us that the acceleration of this boat is negative 3.5 meters per second squared, meaning that this boat is slowing down while approaching the lighthouse. And it wants us to solve for the time that it takes for the boat to reach the lighthouse. So just like your other kinematics problems, what you're going to do is try and find a kinematics equation that uses all these variables that you're given, but then, and again, does not omit any variable, but then again, you do have to omit one variable that you're not given, or it's not a known. In this problem, we pretty much know everything but the final velocity. So as far as the final velocity would be right here when it reaches the lighthouse. We're not given a final velocity. We know it's slowing down because of the acceleration, but we don't know the magnitude of that velocity. So just by looking at our equations here, we're going to find an equation that does not include the final velocity. So just looking at this, this equation right here, the second one, includes our distance, which we do have, our initial velocity, the time, which is what we're trying to solve for, so of course we're going to need that to be a part of our equation. We have the acceleration, again, the time included. So it looks like this is the equation that we're going to want to use. Now, if you notice, you have your time given in t and t squared. Because of that, you're going to have to use the quadratic formula to find your answer, because you're not going to be able to solve for t unless you use the quadratic formula. So I have that as well on here. So let's just start out by writing the equation over here that we're going to use. T squared. Okay, so it says that our final x, which is 100 meters, minus our initial x, which is at 0, so the change in our x will be 100 meters, is equal to our initial velocity of 30 meters per second times the time plus 1/2 of the acceleration, which is negative 3.5 meters per second squared, times our time again squared. And that we can solve for the time. Now when we solve for this, the only thing I'm going to do really is just take 1/2 of negative 3.5, which is negative 1.75. So I'll just rewrite this. So 1.75 t squared. And since we have the variable t and t squared, what we're going to do is move everything over to one side so that we can apply our quadratic formula. And when you're doing the quadratic formula, you're going to want your squared value to be your a, you're going to want your t value to be your b, and your constant to be your c. So I'm going to rearrange this, and when I do so, I'm going to get that my a, I'm going to move everything over to the left side. So my a will be 1.75 t squared. My b will be negative 30t, and again these switch signs because I'm moving them over. And then my c, my constant, is just going to stay at 100, staying in that side. And that's going to be equal to 0 because I have moved everything over. So I'm going to use this formula right here, just plug in my values, so again my a, b, and c, into this equation. Now you're going to be getting two different numbers when you plug that in. You're going to take the smaller number that you get to be your correct answer. So, when I plug that in, my x is going to be, so my negative b value, which is just going to be 30, because negative 30 is positive 30, plus or minus, again, I'm just following this formula, the square root of b squared. Since I'm squaring it, I can just leave it as a positive, it doesn't really matter, minus 4 times my a, which is 1.75, times my c, which is 100, can barely reach right here, all divided by 2 times my a value, which again is 1.75. And then when I do this on my calculator, I'm going to get that x, which is going to be your t, because that's what you're trying to solve for. But your x is going to be 12.6 and 4.53. You're going to get 3 different answers because you're taking positive and minus. And again, your answer is going to be the smaller one, 4.53. So your time, you can say, is equivalent to 4.53 seconds.